Okay, this problem deals with another experiment that's done to extract some measurements of material properties. Here, we're asked to look at this apparatus that's used to determine both the thermal conductivity and the specific heat or heat capacity of a material. And the design is similar to the previous problem that we looked at in the sense that we have two samples. In this case, they're identical samples of materials, and these are attached end to end so that a heater is sandwiched between them. So you have two samples that are attached like this, and in between them is a heater. That design, as we talked about in a previous problem, is chosen to minimize heat loss that might happen through the sides of this geometry so that the heat is primarily being conducted in the vertical direction, and therefore we can use one-dimensional heat transfer analysis to consider this problem. This is a little bit different than the previous problem in the sense that we're applying a time-varying heating to get some additional information about the material. So the basic idea is the same. We have two disc-like samples with some height L and some diameter D that have a heater sandwiched between them. We know what the initial temperature is associated with this location where the heater is placed, and we know that each of these samples has a mass of 78 grams. Now we're also given some information about the time dependence of temperature as it relates to the heat that's applied to this material. So when the heater is switched on, the temperature is going to change, and that temperature change is expressed by this equation.